Alright, so now let us look at another three examples about series. So first one, n to the power of n over n18 to the power of n squared. Okay. Now, for this one, we have, those exponent format, and ratio test might not be the most effective way to start, but instead the twin brother root test can be a key for this problem. So the root test is limit the nth root of this absolute value of an. Okay, so that's the root test. The conclusion is exactly the same as ratio. If capital L is less than 1, absolute convergent, capital L is greater than 1, divergent, and capital L equals 1, basically this test fails. Okay, so now let's actually take a look at this using the root test, which is nth root of n to the power n 18 to the power of n squared. Okay, I didn't put the absolute value because this is already positive. So it turns out what I have here is I'm going to have n here over 18 to the power of n. Okay, and then starting to evaluate this limit, right? So let n goes to infinity. So this is an infinity over infinity type. So I can apply the L'Hopital rule to figure out the derivative of n with respect to n is 1 over the derivative of the bottom is going to be 18n times log of 18. Okay, and as n goes to infinity, this equals 0. Okay, this equals 0. So based on the root test, this capital L equals 0, so it's less than 1. So this series, it converges. Okay, so that's using this root test. Okay, now let's look at another one here. This series is 2 over n and then times the nth root of n. Okay, the nth root of n. And for here, guys, there is one limit result that will contribute for solving this problem. That is limit as n goes to infinity. The nth root of n actually equals 1. Okay, equals 1. About how do we figure that out? You can check in your textbook, but the central idea is, we take the logarithmic of this and then starting to evaluate that value. Okay, but anyway, we can use this limit result to think about this. If as n goes to infinity, this part equals 1, do you agree that asymptotically, when n is extremely large, the term actually behaves very, very close to 2 over n, right? 2 over n. So from that, we can think about using the limit comparison test. Let it to do a comparison with 2 over n. Okay, and we know that this comparing series, it diverges because it's a harmonic series, right? here, and you know, so limit as n goes to infinity 2 over n times n nth root, and then over this 2 over n, right? So it turns out this is limit that is 1 over nth root of n here, and we know that this limit is going to be 1. Okay, so based on the limit comparison test, this series diverges, hence this series diverges also. Okay, so this is the second example. Okay, maybe let me label 1, let me label this as 1, label this as 2. Okay, and then look at last one. Okay, so this is 1 over n factorial here. And how do you handle this? Well, it turns out, you know, anytime when you have factorial, always think about it, the ratio test. Okay. Which an plus 1 over an, that is 1 over n plus 1 factorial, right? Over an, which is n factorial over 1. Turns out it's 1 over n plus 1. Now we know that as n goes to infinity, this limit equals 0. So based on the ratio test, my series converges. Okay. So from this short video, you know, you see the first one use root test because of the format. Second one, we use the limit comparison test. And the third one, we use the ratio test. Okay, so it really depends on the expression of the given examples that you can choose the different methods to figure them out. Okay, so hope you enjoyed this video, and thank you for watching.